Introducing the Icebreakers Sustainable Energy Challenge. This is Grimsey, 40 kilometers off the north coast of Iceland. It may not come as a surprise that Grimsey experiences the worst of the Arctic weather. Fishing is the main source of jobs for the 100 people who live here. This industry, however, is under threat with its shrinking quota, and of course this threatens the prospect of staying on the island. The island relies solely on 3 diesel generators to power their everyday lives. This is not a clean or sustainable source of energy. Both the rising fuel prices and the prospects of job loss on the island have pushed us to find a sustainable energy solution. There are 2 main components to our solution: power generation and energy storage. Grimsey uses an average of 200,000 liters of diesel a year. Each liter of diesel would amount to 10 kilowatt-hour of energy. This would amount to a total of 2 million kilowatt-hour annually. This table shows the 2 different options for sustainable energy for the island. On the left, we have tidal energy. On the right, we have wind energy. The calculation is based on the total energy needed for Grimsey and is based on our calculations from real-life projects. We calculate the energy produced per turbine, then calculate the number of turbines needed. Transportation is factored with each turbine needing 1 trip. For wind turbines, the part would be shipped from America, while the tidal turbines would be shipped from mainland Europe. Since we need 9 wind turbines, the transportation would surpass that of tidal turbines. The next factor we take into account would be maintenance. We take the total cost of a period of 28 years because the batteries we are using have a 7-year lifespan each. Therefore, we are taking 4 parts of this lifespan. For a 28-year period, the maintenance for tidal energy would be less. The total cost of a 28-year period for wind energy would be close to $7 million. For tidal turbines, it would cost $6.2 million. Tidal turbine wins in terms of cost. Having now decided that tidal energy is the more cost-effective solution for this community, we now deal with energy storage. Turbines cannot produce energy at a constant rate. Energy storage will help buffer the difference between supply and demand. When supply passes demand, energy is stored. When demand surpasses supply, the stored energy is drawn out. The 2 main storage options we looked at were hydrogen and batteries. Hydrogen storage systems involve the electrolysis of water, which allow the flow of electrons and which allow electricity to be stored and transported. However, it only has an efficiency of 30%. Batteries, on the other hand, have an efficiency of 90%. Energy is stored in the chemical form. The main strengths of the battery are easy to change, the reliability, and the long life. The total cost of the batteries needed for our project would be $1.6 million. However, these batteries have a lifespan of approximately 7 years. Therefore, for a period of 28 years, we would need to change the batteries 4 times. So, the total cost would then be $6.4 million. The total cost of the entire project would be $6.2 million from the tidal turbines added to the $6.4 million from the batteries. This would amount to $12.6 million. Finally, if we join everything together, we have a sustainable system for Grimsey. Thank you for watching.